Well, it's only recently that we really started to uncover some of the fundamental properties of these particles and understand them better. One of the things that we understand now is that there are 3 types of neutrinos, or species. My illustrious colleague Art McDonald likened this to having 3 types of donuts. So the process we're studying is what we call neutrino oscillations. And basically what happens is a neutrino gets created in one of these species, and then after some time, it may appear as a different species. We're studying this by basically, in Japan, using an accelerator to produce a neutrino of one type and sending it 295 kilometers across Japan to this superconductivity detector, this enormous tank of water that allows us to observe these neutrino interactions. And we're seeing, in fact, there's this transition in the neutrino species.
So this is a bit like getting on a high-speed train and seeing if you came on eating one donut, and by the time you got to the other end, it was a different flavour of donut.
Right. Yeah.
I mean, first of all, it's weird that VCs can have this identity crisis, but more importantly, what is important about that identity crisis?
Well, we have neutrinos, and then we have their antimatter counterparts called antineutrinos.
Just like you have electrons and positrons that antimatter to each other.
And so we're trying to see whether this neutrino oscillation process in neutrinos is different with antineutrinos. That's interesting for many reasons, but one of the big issues confronting our field is the fact that, well, we have a little problem where we're having a difficulty trying to explain the existence of the universe. Following the Big Bang, all this matter and antimatter got created, and the physics that we know now says that it should have just all annihilated away, and so there should be nothing left.
Just light.
Yes. Well, in fact, we're here, right? And there are people, there are planets, there are galaxies, all made out of matter. What we understand now, looking at the universe, is that something like 1 part in 10 billion of the matter somehow survived this epic annihilation, and that remaining bit is basically all the matter that we see in the universe now.
And the lever that you might get to explain that 1 part in a billion or 10 billion is the neutrino.
Exactly. In particular, how matter and antimatter differ, how do neutrinos and antineutrinos differ.
Now, the reason we asked you to come into the studio was because, as I understand it, you are finding a difference.
Usually look for these. They can be found during the review process, and other journals do kind of systematic checks. And Nature does that randomly, and they did not do it for this paper. One of the big changes that is going to come out of this is that Nature is going to, has promised to start doing these kind of checks more systematically. The other thing that led to these papers being published, I think, is that the co-authors were all saying that they had replicated it, or that they had seen a replication, or that they were basically vouching for the fact that they had seen this done.
Retracting a paper is in some sense the final nail in the coffin, but is STAP dead yet?
Well, there are several kind of loose ends that still need to be tied up. There are replication efforts that are still going on. One of the co-authors, Hitoshi Niwa, is heading up an effort that they're saying is very, very rigorous, and this is going to show once and for all whether STAP works. I don't think many people are very optimistic that it's going to work. What's interesting, the interesting turn that happened recently, last week, I think, is that they have brought Obokata in to work with him on the results. And this has been a really unpopular decision in Japan, where they want her punished. They don't want her in a lab. They want her in prison, basically. But it seems to be a good idea, because I think she will no longer be able to say, as she says till today, that her technology works.
Now, she may be involved in these efforts and still at large in the work itself, but of course you've been trying to get in touch with her for an interview since April, no dice. What do you know from I suppose, the Japanese media and media elsewhere of how she's faring through all of this?
Yeah, she's been in the hospital for the last few months, and she's made some statements through her lawyer, but when she went back to work last week to help with these replication efforts, the media was hanging out at the research institute waiting for her. In Japan, researchers to look back through all of their papers, so tens of thousands of papers, to look for similar errors that came up in these papers. It's come to the point where there was an independent committee that came out with a recommendation that the center be closed. So it's a very strange, I feel like it's kind of gone off the rails in its outrage.
And as David points out, the postscript to the saga is yet to come. In late July or early August, the ongoing replication efforts will wrap up. In November, you can expect a verdict on how Obokata and her co-author Yoshiki Sasai will be disciplined, and the stem cell world will also have to wait and see whether the Riken Center for Developmental Biology will be closed. David Sironowski has written extensively on STAP cells since they exploded onto the scene in January. His latest feature is out this week, and you can find that piece and an editorial about the retractions in a news special, The Rise and Fall of STAP, at nature.com/news.
Coming up in this week's research highlights, kangaroo's fifth leg and the exoplanets that are now X-planets. But first, the Cuban tree frog is a remarkable-looking creature with enormous toe pads and bumpy beige skin like a toad. At up to 5 inches long, it's the largest tree frog in North America. But like many other amphibians, it has a nemesis, the chytrid fungus. The nasty fungus slowly eats away at the frog's skin, making it difficult for the frog to control its body's water content. Consequently, the muscle tissues don't work properly, so the heart slows down and eventually stops. The chytrid fungus is decimating frog populations worldwide, wreaking havoc on ecosystems.
change material. These materials can change their properties if a laser or an electric current is applied. They sounded and took centuries to solve. An exhibition at the National Maritime Museum in London takes a long look at longitude, and I've come to take a look around with senior curator Richard Dunn.
Tobias Meyer, and also tested alongside a third method, a marine chair for observing Jupiter's satellites.
What was the idea? You just sit in the chair and look at the sky?
Basically, but you needed to be very steady to observe Jupiter and its satellites because the field of view is so small, and that was it. It was a chair for holding a telescope very steady, and it couldn't.
Have modern sailors appropriated these techniques, or do we now find our way in a totally different fashion?
Modern sailors still have these kinds of techniques available. With the coming of GPS, they aren't the main way of navigating anymore, but GPS might fail. So the British Navy and others are thinking about actually making sure they've got far more officers trained in traditional astronomical navigation systems than they might have done only a few years ago.
That was curator Richard Dunn at the National Maritime Museum in London. Find out more about the exhibition and check out some pictures of Harrison's clocks on the Royal Museum's Greenwich website at rmg.co.uk, or follow the museum on Twitter at NMMGreenwich. Hey, and follow us on Twitter too for show updates, anecdotes, relevant links and non-relevant links. We are at Nature Podcast.
Time for the news now, and news editor Davide Caslavecchi joins me in the studio. What's your first story this week?
The first story is about yet another embarrassment in biosafety. It was announced that the Centers for Disease Control and Prevention in Atlanta, Georgia, have accidentally shipped a highly infectious vial of the flu virus H5N1